Audible? Guys, am I audible? Yeah, audible to others? All right. Okay, cool. Let's start then. So we've been looking at 2D DP. We started with two-dimensional DP yesterday, and we were looking at, in particular, what kinds of decisions and sub-problems we will get in case of a 2D DP. So can anyone summarize all the types of decisions that we have encountered so far? Should I take a name? Let's take a name then. Maybe Rohan, can you do that? I think you were there in all the classes, right? Yeah, I mean, can you unmute and speak? Okay, your mic's not working, then let's try someone else. Who would like to summarize? Tushar, maybe. Tushar to कर ही देगा. Tushar, can you summarize? किसी का माइक काम नहीं कर रहा है क्या? किसी का कर रहा है माइक काम? Can anyone summarize all the decisions that we have encountered so far? So let's go one by one. In 1D DP, when we started, we looked at what kind of decisions we looked at. We looked at the include exclude decision, right? Then we looked at the decision wherein we were finding out the predecessor, correct? What else did we look at? So in the include exclude decision, we said we could either choose to include this element or not include this element. In the predecessor, we said that we want to, for this particular element, we want to find its predecessor in the chain that we are looking for, right? What else decisions did we encounter? Yeah, we looked at the first element of the solution, correct? So we said that let's look at the first element of the eventual solution, and it could be this, it could be this, it could be any of the elements from the sequence or from the set that we are given. So based on that, we made a decision that the first element could be any of this, right? What else did we do? So this was in the first element, we looked at partitioning questions, right? We looked at word break and we looked at palindrome partitioning, correct? And then there were questions wherein the decision was explicit in the question itself, right? So it was given that from here you can make so and so, you can do this, right? Like for instance, we looked at the gaming question, wherein we said that, okay, so in the gaming question, what did we look at? We said that Alice could take first element or take the first number or the first two numbers or the first three numbers. So that was an explicit decision that we had, and based on that, we defined a sub problem for us, right? Is that all? Did we look at any other type of decision? Why is the involvement so low today? Is there something today? Thursday shouldn't be a lot of. So after that gaming question, what else did we do? We looked at, so in the explicit, we looked at quite a lot of code forces. तो ठीक है यार, तो होता ही रहेगा. In the explicit decision, we looked at the game question, right? Then we looked at the arithmetic, the question wherein we had to give every number a plus or a minus sign such that the total sum equals a given sum, right? So that was also an explicit, we called it arithmetic slices or something, right? So those were like the questions wherein we saw explicit decisions, right? So I'm just summarizing what we have done. In the first lecture, if you remember, we looked at, to begin with, we looked at the include exclude decision. Then we looked at a lot of questions involving subarrays. And in the subarrays, we said that we want to find the longest subarray satisfying that property ending at a given index. And there the decision that we made was who could be its predecessor. That element itself could be the predecessor, or it could be an element from before. Like if I is the element that we are at currently, either I is the predecessor or I minus 1 is the predecessor for subarrays, right? And then we looked at then we looked at 1D order n square questions, right? In 1D order n square questions, we looked at subsequences satisfying a certain property. So in subsequences satisfying a certain property, we said that we again want to find the subsequence, longest subsequence satisfying that property ending at a given index. And there we said that the predecessor could be any j less than I, right? So in that way, the nature of the problem became an n square problem, correct? Then we looked at another type of problem, which could potentially be an n square problem, where we looked at word break. We said that the first partition could be any of this. And if the first partition is this, then this is what we are left with. So that also resulted in an order n square 1D DP, right? So these were covered in day 2. Then yesterday we extended that and we looked at the gaming question. So yesterday we were looking at questions wherein we had explicit decisions. We took the question where Alice and Bob were playing a game, and we said that whoever is going next has an option of picking the first element, the first 2 elements, or the first 3 elements, right? And there the decision was explicit. The decision was not something that was difficult to come up with. And then when we started with 2D DP, we looked at a question wherein we had to give every number a plus or a minus sign such that the total eventual expression evaluates to the sum that is given, right? So there also the decision was explicit. You knew that at a given index, that particular number, you only have 2 choices. You could either give it a plus or give it a minus. And based on that, you formulated your recurrence, right? And then we started with knapsack. So in knapsack, what did we do? We looked at 2 decisions to solve the same problem. So in knapsack, we said that we basically have a sequence of numbers, and we have to find every number we can take 0 or more times, and we have to find the maximum that we can make from this, which is less equals a given target, right? And there we said that there could be 2 ways you could go about doing this. You could think about the first element, which was this decision. You could think about the first element of the eventual solution, the solution which gives you a sum which is as large as possible and which is less than equals to the target, right? And there we said that the first element could be any of this. So that was this decision. Other way you could do the same question was you could include it 0 times, or you could include it greater than 0 times, a particular number. So if you are including it 0 times, you had this particular array that was left and a sum of target which was left that you need to find, right? And if it was greater than 0, then you take it once and your sub problem then becomes this array itself and sum minus A0. Correct? So that was kind of a decision from here. Right? Is everyone with me so far? Are you able to recollect, people who have been there in the classes? How many of you are able to recollect? I just gave you a brief summary of all the types of questions that we have done so far. Does that make sense? Like, right? So pretty much. Yeah, sir.
I had a doubt. The last problem, we had already done it in recursion classes, right? It is the same or different one?
Which one? Which one?
Target less than, sum is less than equal to target, that model.
Had we done that?
Yes, we have done that in recursion classes.
Yeah, that was the combination sum question, right? Wherein we had to, yeah. But that was, we had to find a combination which would, yeah, I mean, it was also, it was, I think, yeah, you're right. I think it was similar. Was it exactly the same? So here you have overlapping problems, right? How is this, and how does this have overlapping problems? If you, let's talk about the first type of decision. So yeah, Harsha, we will discuss that question in deep today. That is basically the knapsack problem. I will introduce it formally to you. So after that, maybe it might make more sense. Okay. Okay. So everyone is with me so far here. Nobody has lost me, right? So these are pretty much the major decisions that you have to make. Mostly, even in recursion backtracking, as well as in DP, these are pretty much like the major types of decisions that you can make. Most of the questions that you will get will have explicit decisions given to you, that at a particular step, these are the choices that you have. So now make one of those choices. And depending on the choice that you make, you are left with a sub problem. So pretty much most of the difficult questions are from the explicit decision category. So let's then, if this makes sense to all of you, let's continue with our discussion of knapsack. So let me introduce the problem more formally to you, and then we will see how this goes. So in knapsack, what happens is you are given a set of objects. So you have a set of objects. Each of these objects have a certain value. Okay, and each of these objects also have another feature, which let's say you can call them weights. Now the knapsack problem essentially tells you, so these are values, or you can call them importances or significance, and these are weights. You could have multiple variants of the same problem, but essentially for an object, you are given two attributes. Any two types of attributes you will be given. Mostly, like in most cases, these are values and weights, but you could be given any other types of attributes also. And you are given a target. What you have to do is you have to pick up elements from this, pick up objects basically, such that their sum, the sum of their weights is less equals target, and their values, the sum of their values is as large as possible. This is roughly the problem that is given. So just to give you an idea of where this is used or what is this, this is basically, imagine a situation like you have to carry clothes. You are traveling and you want to carry clothes. So each of these clothes have a specific weight. So your suitcase or your briefcase only allows a certain, has a capacity or has a upper bound on the total weight that it can carry. right? So you have to pick up clothes from your wardrobe in such a way that you should not exceed the target capacity of the briefcase. But at the same time, you want those clothes to be of high significance for you. So the total significance sum for all those clothes should be as large as possible. This is just one scenario wherein you can adapt knapsack. Is this clear? Does this make sense to you? Like the definition of knapsack, what it is, and like one potential use case I just told you. So this is the problem at a very high level that you want to solve. And how can you solve this? It is very, you could go about, now there are two types of knapsacks. You have unbounded knapsack and you have bounded knapsack. So in unbounded knapsack, what happens is you have infinite quantities of each of these objects. So there is no upper bound on the number of objects of each type. You can take as many as you want from a particular of a particular object. That's basically called unbounded knapsack. And bounded knapsack is basically you have only at most one piece of every object, and you have to do the same, right? So that is basically the problem of knapsack. Let's discuss unbounded knapsack to begin with. So in unbounded knapsack, what is the decision that you can make? You have objects with weights and you have significances of each of these. You are given a target weight which you cannot exceed. And you have to maximize the value, the significance, such that the sum of the weights is still less equals target. What is the decision you could make? You could have two types of decisions. Let's talk about the decision wherein you are looking at the first element that you choose, the first cloth that you pick from the solution. So that could be any of these, right? Now, let's say it is the ith cloth that you pick. If it is the ith cloth that you pick, what is the sub problem you are left with? You have to now find out, or you have to now maximize the value from all the other objects, including this object. But now your target is target minus Wi, right? So if I say that F, so if now I say that F target gives you the maximum value that you can obtain, max value that you can get, such that the sum is less equals target. And you could write this as, if you choose Vi, you could write it as Vi plus F of target minus Wi. You will also have a total, right? And you have to maximize this across all i's. This is the decision that you could make in this case. Is this decision clear to everyone? Is there any question on this? I will just take a pause and you can ask me questions if you don't understand any aspect of this decision. If it is clear, you can acknowledge so that I can move on. Yeah, Akash. So max is basically what we are saying is you have to maximize the value, right? So F of target returns the maximum value that you can get. Okay. So if you choose I, then you are left with target minus Wi. That is the that is the maximum capacity that you can have now. That is the maximum that your luggage or your briefcase or your suitcase can accommodate, right? So now you have to find the maximum value that you can get for this capacity from the same clothes or from the same objects. That's why we do not have the clothes as an argument here, because it is not changing, it's the same, right? And you could, the point here is the first element could be any of these. So I am trying out all the possibilities. If the first element is 0, then what will I get? I will get V0 plus F target minus W0. If the first element is 1, I will get V1 plus F target minus W1, right? So I don't know which is the first element, but I am trying out all possibilities. So from all these possibilities, whichever I gives me the maximum, Vi plus this, that will be the first element in the solution, right? So that's why there is a max here. Karan, is this making sense? Dreshan, is this making sense? Prapti, Pradyum, Vishwa, you guys come every day, right? Karmanya, Ayush, Ishan is not there today, right? Okay. So that is the decision. What is the other type of decision that you could make? You could make a decision where of type include exclude. Right? So if you include you could either include the include exclude decision could be made on the first element. So if you can choose to either include it one or more times, or you can choose to exclude it altogether, right? So if you choose to exclude it altogether, you are left with, so you have two choices here. If you choose to exclude it altogether, then you are left with 1 to n minus 1. These objects you are left with, and you have a target to fulfill. So whatever maximum value you can get from these clothes such that their weights sum up to a value less equals target, that will be the answer, right? And if you choose to include it at least once, then you again have 0 to n minus 1, all these clothes, and you now have a target minus W0. Now you have to maximize from the existing set of clothes such that the total weight does not exceed target minus W0, right? So these are the two choices that you have. So what you will do is you will take the whatever, and you will get a V0 here already. Here you don't get anything. So you will have to you will basically maximize for take the maximum out of these two. Right? Is this second decision clear to everyone? So in the second decision, you basically, what is the sub problem that you are left with? You are left with a suffix array and an integer. So you have a 2D DP here. In the first, you are left with only the target minus Wi. That's the sub problem that you are left with. You are left with an integer. So this is a 1D DP. But both of them will take order n square time. So that basically is the unbounded knapsack problem for you. So the question that we looked at yesterday, wherein we were given just a set of values and we have to pick 0 or more of them such that they sum up to a value less equals target and are as large as possible. There you had W and V as the same array, right? So let's now, so that is also one variant. So let's quickly code that solution, and then I will come back and talk about the bounded knapsack problem. So I will just paste the link of the question that we are doing for people who are coming after a long time, or So there is no question number here, Purva. So this is just the hackering problem. So, but for lead code, I will give you question numbers. So let's code this then quickly. So you are given an array and a k, and you have to determine the sum nearest to but not exceeding the target that can be created. To create the sum, you can use any element of the array 0 or more times. So here let's talk about the first type of decision that we use. Let's talk about the decision wherein we look at the first solution, right? So the first element of the solution, let's talk about that decision. So for that decision, what was the sub problem? Our sub problem was a suffix array. No, our sub problem is just an integer, right? So what will be the range of that integer? It will be from 0 to k, because k is the maximum that you can form. Correct? And what is the strategy in DP? I told you have to think about the strategy of filling values for the sub problems. So what is a smaller sub problem here? A smaller value of k, right? So what we will do is we will start filling from the smallest value that k can take to the largest value that k can take. Okay. So what we will do is we can run a loop. This is okay. So we will fill from the smallest k to the largest k. So I will start from the smallest k that I can take is, so what is the base case? K1. Right? The smallest value of k that is possible is 1. So the base case would be K1. What would I fill for K1? 0 you can fill, Ayush, I think. Yeah, I think you could, but k here takes from 1. You can fill from 0 also. So what will be the value we'll fill for 1? It will be dependent on if I have, yeah, it will depend on the smallest. We can accommodate that here only in the loop. So we are going from the smallest to the biggest. Now for a given k, what we have to do is we have to find out the total, the maximum that you can get, which is less equals k. So here we have to find for a given I, we have to find if we pick up 0 or more elements from the sequence, what is the maximum we can get, which is less equals I, right? So now we will employ the decision here. The decision was that we can pick any of these, right? So I will go over each of these one by one. Each of these could be the first element, right? 0, 1, J0, J1, J2 for a given I. So if I pick up this current one, what do I get? What am I left with? I am left with I minus array of J. Right? That's what I'm left with. And now I have to solve for this. Let's create a DP first. For k, if we are going from 1 to k, so for kth index, we'll need k plus 1. So we can just check if I minus array of j is greater equals 0, then I can say that dp of I is maximum of whatever I have so far and array of j plus dp of I minus array of j. Right? So that's it. And then I will return dp of k. What is the expected output? No, this is only passing for this test case. Expected, so they have two test cases. Yeah, in the driver code we have to make changes here itself, right? They're just calling it. Tell me the line number. Oh, they're not, but that's bad, man. But how many cases? So they are taking nk. Let's go through the driver code. They are taking the number of test cases, which is fine. And then they are for a given, they have not, this will be in a while loop, right? Right, Sitish? ठीक है, ट्राई करते हैं, देखते हैं कहाँ पर ये रोएगा. अरे नहीं लेना है मेरे को इनपुट अभी. ओके. I don't know what is screwed up. Yeah, let's just. We have a function also which we are calling. So for every test case, I am running. हाँ, t minus minus तो करेंगे ही, but let me just see ये function क्यों हमने select कर लिया. Let me only select. रुक जाओ एक सेकंड. So they have a split. We just need to copy till here. It's not even going up. Just do it here only. So you have a t minus minus, you take the input, you split, you initialize, you call your function, you output it. This looks okay now. Okay, so that's okay, whatever I did. They were not looping over all the test cases. So that's what I just did. I just put their code in the loop. which is fine, but this is essentially the logic. Okay, this logic is clear to everyone. Can you acknowledge? We will try the other type of decision then. Crystal clear? So let's try the other type of decision then. Okay. So the other type of decision is, let's recap what we will do in case of the other type of decision. What will we do in the other type of decision? What is the sub problem that we are left with? We are left with a suffix array and a sum. Correct? So now let's see. So what is the next step in the process? After, so what were the total steps? You basically should figure out the decision. Based on the decision, you should formulate the recurrence. Once you have the recurrence, you should get an understanding of the sub problem. So when you understand the sub problem, here in this case, we have a suffix array and a target, which is an integer. Right? The next step should be, you should try to simulate the DP. So by simulating the DP, you should determine the order in which you will fill the sub problems. Right? We discussed this yesterday. So here, what is the total space of our sub problems? We have a suffix array. So let's put all the suffix arrays row wise. So let's say this is the entire array. This is 1 to n minus 1. This is 2 to n minus 1 and so on. Finally, you will have n minus 1 to n minus 1. And you have all possible values of the sum. Right? So sum could go from 0 to k. Right? And now you should think about order in which you are filling the sub problem. So what is the decision here, if you remember? If you take 0 times, then you are left with 1 to n minus 1 and the same target. If you don't take, if you take, then you are left with 0 to n minus 1 at t minus a0. Right? So let's stand at a particular cell and see how we are filling that cell. So let's say we are standing here. How are we filling this cell? You have two possibilities. If you don't take it, you are filling it from this row, right? You are filling this value, the same target for 1 to n minus 1. So at when you are at a given I to n minus 1, for the same target, you are filling from I plus 1 to n minus 1. Right? So this is one value that you are using when you want to fill this. Everyone understands this? Do you understand this? This is important, that's why. And what is the other value that you are filling? The other value you are filling from somewhere here, right? One of these values, which is t minus a0 for the same suffix array. Correct? One of these values. So you are using these two values to fill this value. So what is one strategy or one order in which you could fill this space of subproblems? You could fill it row wise. You could fill it in this order. From here to here, then from here to here, then from here to here, then from here to here. So that will ensure that when you are at a given I, you have filled all this and you have filled all this. So you will have those two values readily available to use. Does this make sense to you guys? Do you understand the essence of this? We are trying to understand the order in which we will fill our subproblem space. And I am saying that we just looked at the recurrence, and from the recurrence, we concluded that these are the two values that we are using. So if I go ahead and fill my 2D DP array in this order, then I will always have the value for the smaller subproblems when I am about to compute for a bigger subproblem. So that's basically what I use. So my skeleton of code would be that I would run an outer loop for the sub array. So it will go from 0 to n, and in the inner loop, I will fill for a given row. I will fill from the smallest to the largest. That will be my order. So Swami, repeat the second filling. Yeah, Swami. So you understood the subproblem, right? You understood the decision, you understood the subproblem, right, Swami? So now we are just trying to determine the order in which we will fill out the subproblem space. And there we are saying that when we are at a given step, we are using the value from the immediate row before this in the same column, which is this 1 to n minus 1. This is I plus 1 to n minus 1, right? And the same target. So the same column, the previous row value we are using. And for the other case, we are using the same suffix array, but a smaller value, right? So when we are here, we are using one of this value. This is the same suffix array, one of the smaller value, right? So we are saying that when we are here, all this row should be filled and this should also be filled. Then only I can use these values to fill this value. And that's why I'm saying that we could do away with row wise filling. So we will start from this will be n minus 1 actually, and 2, 0. So we will start from the bottom, and this will be the skeleton of the code. Karan, is this clear? The second filling also, is it clear? Yeah. So this is the decision. This is another analysis that you should do when you have higher dimensional subproblems. So let's try that here. So our DP is a 2D array now, right? So this is basically include, exclude. And our subproblem is a suffix array and an integer. And our strategy is fill it row wise. So I will define the DP array. So my DP array has n elements, and for every I will have k plus 1. And now how will I run this loop? I will fill it row wise, as I said before. So I will go from the smallest, which is this, and my j will go from 0 to k. Now you have two decisions, include, exclude. Let's say you are excluding it. If you are excluding it, you are left. So now for a given ij, you have to fill. So if you are excluding it, then you have the same, you have I plus 1 and the same sum that you want to form. We will have to take care of I plus 1 here. So that is the smallest case, right? So let's take care of it here only. I mean, you could take care of it at the other way. So if, or the other way you could do it, it is you could have this. Let's do it that way. So if you exclude it, you have this. If you include it, you will have whatever you have gotten so far. And if you're including it, you will include array of I. And now you will try to get from I plus 1. You try to get from the same I, but for some j minus array I. Just have this case. Right, and then you will return the 0 of 0 and k.
Sir, you could directly you could directly write include and exclude at both steps. I mean, in a single step, right?
This test case you have to just take care of, this boundary case, that j minus array I could become negative. That's why I have just separated them. If I write dpij is max of dpi plus 1j comma this expression, then I have to take care of this case, right? So when this is negative, then I will have at least this case, right? I will have at least this value in the dp.
Yeah.
Yeah.
But
So
instead of dpij in the line number 23, in the instead of dp of ij, we can just write. Can we write dp of I plus 1 comma j?
Here you mean?
Yeah.
Yeah, you can do that. It's the same thing only, right?
Yeah.
So now you see, now let's do dimensionality reduction on this question. Yeah, we will do the space optimization right now. J should be from 1. Yeah, you could run J from 1 because we have initialized it to 0. So it should be fine. Okay, Pranav. But you could run it from 0 also. It does not matter. Right, Pranav? You could run it from 1. You could run it from 0. We have initialized. The best part is that we have already initialized it to 0. So otherwise we'll have to initialize it for 0. Yeah, now you look at this
Sir,
thing.
one doubt.
Yeah, sir.
Sir, if we are filling it with column wise.
Column wise, okay.
Yes. The J loop will be above the I loop, right?
If you are filling it, you have to fill it. You can define row and column in any way. If you want to have k as the row and suffix array as the column, you can have that, and then you can fill it column wise. Here, you cannot fill it column wise. Or will column wise also do? I think column wise will also do here, right? Because you are just using. Yeah, I think column wise will also do. Why will it do? Yeah, if you are going from bottom to up, it should be fine. Why? Because we could do it column wise. You are right, Harsha. See, because when we are at a given, the same idea, we are here, right? We want to fill this. So if we have done it column wise, then all these are already filled and this is filled. So I think we have everything. We need this value and we need this value. So we have both of them. Right, Harsha? So we can do it column wise also, yeah. Then the outer loop will be for k and the inner loop will be for the suffix array. So you are going from k0 to, and the outer loop will run from 0 to k, and the inner loop will run from n minus 1 to 0 because you're filling it in this order. And this was the smallest. So you can do it that way. That's a valid way of filling. Does everyone understand Harsha's point? That's a valid point, and that's also one way you could fill it, right? Yeah. So you could fill it that order also. Now just one more thing, which we did yesterday also. When we are at a given I, we were just using the previous row and this row's previous value, one of the previous values from this row and the previous row. That's it. We are just using two rows, right? So one thing I could do is I could space optimize. I could just have space for two rows, right? Then what I will do is I will have a modulo everywhere. And I can return 0 modulo 2 is 0, but let's just try it. So I could do this also. So yeah, everyone understands the space optimization that we did here? We cannot do it with one, right, Karan? Because you need one of the values from the current row and we need one of the values from the previous row. So this solution again is order nk and has a order k space. And with the previous decision also we had an order nk solution with space k. So ultimately, no matter for both the decisions, we have arrived at the same space-time solution with the same space-time complexity. Okay? So this is unbounded knapsack. I will take a pause and take questions if there is anything. If not, you can acknowledge that you understand unbounded knapsack, and then we will move on. Okay. So then try this question. So how do you do this? Lol. This is simple, right? This is not tough. How would you do this question? Yeah. Repeat unbounded knapsack for each friend. Correct? Everyone understands that? So you can try it on your own. This is just one, they have asked this question a lot of times, like, because it's just a knapsack with a little bit of change. That's also a very trivial change. So if you understand that, let's discuss the bounded knapsack. So in the bounded knapsack problem, the situation is so in the bounded knapsack problem, you have the same thing. You have weights and you have values. The only difference is that now you have to, again, you are given a target. So you have to pick up elements from this set of objects such that their weight does not exceed the target and their values are as large as possible. But the only constraint is that you can only pick an element at most once. Correct? So let's try. What decision can I try on this? What decision can I try here? Yeah, you could try the include exclude decision. So let's try the include exclude decision. If you include it, then you are left with 1 to n minus 1 and target minus W0, right? If you exclude it, then you are left with 1 to n minus 1 now again, and the same target. Yeah, we will talk about the second decision also. This is the same decision, right, Karan? Include, exclude. We already did this. Let's try the other decision also. But this is one decision we could do. This is a 2D DP. We could fill it row wise. This is again row wise filling, and we could get the answer, right? What is the other type of decision we were making? We were talking about looking at the first solution, right, Karan? So let's try the first solution. What will be the sub problem? Let's say we chose I. What sub problem will you be left with? You will be left with the entire WV array except WI, right? And T minus WI. Right? So what is this? Is this a suffix array, prefix array? No. This is a subsequence. Right? So if this is a subsequence, so what is the sub problem that we are left with? We are left with a subsequence and a target. Right? So if we use so now what is the total space of sub problems here? How many possible subsequences can you have? You can have 2 to the power n subsequences, right? So this will be a 2 to the power n into t space and time solution. right? Does everyone understand this? What if we try this decision on this problem? So yeah, that is that basically. So this is a more efficient. This is an order n into t solution, right? So this is, so these are the ways you could do it. This is exponential, this is polynomial, this is better. So that's how you could go about solving a bounded knapsack. Any questions on this? Do you understand this both and why we chose this over this? So those are the two types of knapsack which exist in the industry and you use them a lot. You mean n into t, Karan? Yeah, n into t. Yeah, n into t time is the best, and order you are doing order t space here, right? Because you are again using two rows. So order n into t time and order t space is the best solution. So that is about knapsack. It's a classical problem that people have solved a lot number of times. People have done a lot number of times, and that's why we did it.
So
Now
why
let's.
Why can't we do this using greedy direct?
Why can't we use the? Okay, what is the greedy approach?
First, we will choose the element which has the smallest value of v by w, the largest value of v by w, such that we can accommodate more elements and v is also maximized.
You are talking largest value of v by w. V is to w ratio you are saying.
Yeah.
So he is saying, why don't we choose the, so for all the v and w, let's find out v by w and take the first to first, the first we should take v by w, the largest. Will that give you always a solution which is as close to, it will not, will it?
Intuitively, I feel that it should.
Let's see. And no, fractional knapsack is different. Intuitively, yeah, it might work. Will it work? Let's say, okay, here you are taking w in the denominator. Yeah, okay. Anyone tried this solution? Like on, if it works, then it's okay. Otherwise, like, I will try to think. So what he's saying is pick the one with the greatest v by w and use it. Okay. So if it works, then Karan, this is the best solution. That was the best DP solution. This is the best solution in this. So this is order n solution, right? You will have to prove why this works, but this is a greedy approach, Karan. We will do greedy algorithms, but basically we are trying, because we have to maximize VI and take as less W as possible for a particular, the intuition is that let me take an element which can contribute the maximum to the value and the minimum as possible, as less as possible to W. So that's basically the idea. That's the intuition for a greedy approach.
Sir,
so we are picking.
We are only allowed to take each element once, right?
Yeah, we will remove that element.
So I found an example on Quora. Like, say, like the weight of the knapsack that we're allowed is the capacity is C.
Okay.
We have two items.
Hmm.
The capacity is C, and we have two items. The first item has weight C and value C minus 1.
Yeah,
And
Mhm.
weight C and capacity C minus 1. The other one has weight 1 and weight 1 and value 1. So 1 and 1.
The other one has weight 1 and value 1. The other,
Yeah.
the first one has weight C and capacity C minus 1.
Not value C
Value
minus 1.
C
Yeah.
minus 1.
Yeah.
So here, if you pick,
the
you will
greedy
pick
one.
this.
Yeah. So
You will pick this one, right? C minus 1.
Yeah. No, we will pick C. The value. No. The value is C minus 1. You have marked it opposite. Like. Yeah. This.
So you will pick this, and you will be left with C minus. That's it. You will just pick this. Yeah, that's a counter. But you should ideally pick this. है ना? Yeah, Ujjwal.
What is the counter? I didn't understand.
Utsav. Take this example, right? We had we were taking weights and values, right? So let's take weights C and 1, just 2, and values C minus 1 and 1. This is the counter. So what will your greedy approach pick? It will pick this second object first.
Yes.
So your value will be 1. So the maximum, and that's it. Your weight, remaining capacity, remaining weight, and let's take the weight as C. Okay, the maximum weight, the target. So for this, you will pick this 1, 1, right? And then you will be left with C minus 1. You cannot pick anything else. But the actual answer is this, C minus 1. Right, Utsav? Yeah, I mean, I barely like remembered कि greedy नहीं चलता यहाँ पर. मतलब I knew, I had a vague memory that greedy has counter examples, but yeah, so greedy does not work here.
Actually, fractional knapsack के लिए greedy चलता है, मैंने अभी check किया.
हाँ, fractional knapsack के लिए चलता है basically, wherein you can pick an element, उसमें से आप पूरा आपको whole नहीं है. Basically in fractional knapsack what happens is that object can be broken down. So any object in these knapsacks, what are we doing? We are either picking a whole object or we are not picking an object. In fractional knapsack, what happens is we can pick a part of that object. So if we can pick a part of that object, then the greedy solution works. So you could read more about it, and if all of you are interested, we could talk about fractional knapsack also. एक केस नहीं है यार करण, इसको तो बढ़ाते रहोगे ना, कब तक एक्सेप्शन डालोगे आप? मतलब this could be an array of size 4 also I can give. This is one generic pattern. Basically the idea is you can still come up with more counter examples. See, you want to make V by W small for a quantity which you don't want to consider. So it will be true for C minus 2 also, right? If you take C minus 2C, then also it will be true. If you take C minus 2C and the target is C minus, and the target C minus 2, C minus 1, and the target as C minus 1, then also it will be true, right? So you can't add an exception. It's not a single case. So that is So let's do more problems on 2D DP. Let's do a classical problem, edit distance. Have you guys done edit distance? How many of you have no edit distance? The problem like this comes up in NLP also many number of times. Others? So I will just, yeah, let's do it. Yeah, keep coming, like keep your votes coming. So far I've seen. So majority haven't done. So we will discuss it. Let's discuss it. So read the question. It's a non-trivial question, again a classical question. So I will tell you the solution, you will agree to it, and that's it. That's the transaction that's there for this question. बहुत difficult है. It is like that. So all these classical problems that you will get, most of them, the transaction will be like that. I will tell you the solution, you will agree to it. हाँ सही है, चल रहा है, cool. That's it. And then you move on. So this is one of those problems. There's like, I will tell you the problem. So in this problem, what is given is you are given two words. Let's take two words. Let's take the same example, horse and Ross. And what you can do is you can perform three types of operations on this. You can insert a character, you can delete a character, or you can replace an existing character. You have to find out the total minimum number of operations it will take to convert W1 to W2. With these operations being the type of operations being allowed, that are allowed. So for this particular example, the minimum as it turns out is 3. The first step you could do is you could replace H with R. So it becomes RORSE. You could delete E and delete S, delete R and delete E after that. So that is delete R, this R, and delete E. So in 3 operations, you will be able to get Ross from horse. So you have to find out the minimum number of operations you need to convert a particular word to a target word. That's basically the question. It has a lot of applications in natural language processing. When we do edit distance is an algorithm which has been widely used in the past and is like used currently as well. If you happen to take a course on NLP sometime, then probably it might be taught, like it was taught to me, at least in my course. What could be some applications of this? So intuitively, this determines the distance, as the name suggests, it determines the distance of the two words, right? So in all types of NLP problems, wherein you are quantifying distances between words or separation between strings, this could be a metric that you could use, right? Yeah, difference between two files is one example, correct? So whenever you are quantifying distances between words, you could use this. You will have a lot of questions wherein you will have corpus of text, and let's say one simple example is you are predicting, like you are predicting the trying to predict the similarity of two text documents, right? So if you are trying to predict that similarity of two text documents, one very simple algorithm you could use is you could find the edit distance between them, and that could be used as a similarity that could be used to quantify the similarity between text 1 and text 2. You could do DNA sequencing. Yeah, Nikita would agree because she likes biology apparently. So in DNA sequencing, you have, what are the sequences? AGCT, right? Right. Yeah, maybe one of you can unmute and tell us the application in DNA sequencing. कोई बताना चाहता है? Yeah, Nikita, maybe you can unmute and talk about it. नहीं, निकिता को पता होगा, थोड़ा ज़्यादा बायोलॉजी पढ़ती है वो.
Hi. So basically, when we have to compare sequences of, let's say, a same family species, so we need to figure out how much a protein has undergone changes. So protein ka sequence hota hai, basically amino acid sequence, which is in fact derived from the DNA sequence. So to determine protein में functional changes कहाँ किए हैं या structural changes हुए हैं, we need to know how much the sequences in the family are changing or matching. So we give a score, and all those predicting scores are based on various matching algorithms, one of which is this as well.
Right. समझ आया सबको? थोड़ा थोड़ा. अरे. Good. ठीक है. So yeah, that is another application potentially. तो अब मैं क्लास में अगले बैच से ये दोनों एग्जांपल यूज करूंगा, सीक्वेंस मैचिंग भी करूंगा. ठीक है. So how do we go about solving this? Now this is tough. This is really tough. Let's say I will just tell you the approach here. Bert and Elmo. अच्छा, MIT में डीपी पढ़ाते हुए एग्जांपल लिया है यार. MIT के लड़के ज़्यादा तेज होते हैं, हम नहीं इतने तेज. OCW वाला ना, the classical one, the one taken by one of the authors of CLRS, right? That course you are talking about ना? हाँ, लंबे बाल वाला. और एक उसमें वो मेन क्लासेस लंबे बाल वाला लेता है, बट बीच बीच में एक दद्दू भी क्लास लेते हैं ना. मैंने तो वही वाला देखा है कभी. OCW, MIT OCW का एक कोर्स है जिसमें कॉर्मेन, CLRS जो कॉर्मेन बुक जिन्होंने लिखी है उनमें से एक ऑथर क्लास लेते हैं और एक वो लंबे बाल वाला लेता है. तो वो जो लंबे बाल वाला है, जब मैंने पढ़ा था उससे तब वो टीए था. अभी अपेरेंटली सुनने में आया है कि वो प्रॉफ बन गया है. नहीं, कॉर्मेन नहीं, वन ऑफ दीज. देयर आर 4 ऑथर्स इन CLRS. आई थिंक चार्ल्स, लाइक वन ऑफ देम. इसमें कौन कौन ऑथर हैं, उसमें से एक ऑथर का एक कोर्स है. ब्लैक एंड वाइट है, 240 पिक्सल है. तो वो टीए था उस टाइम पे, ये लंबे बाल वाला. अपेरेंटली फिर इसने बहुत सारे कोर्सेज ले लिए हैं. हाँ, मेरे टाइम पे वही कोर्स बहुत पॉपुलर था. हाँ, उसने लंबे बाल वाले को इंट्रोड्यूस किया था. तो वो कोर्स अच्छा है एक्चुअली. वो काफ़ी, एरिक, हाँ एरिक, राइट, एरिक, राइट. हाँ, वो कोर्स एक्चुअली अच्छा था उस, हाँ मतलब प्रॉब्लम वही होता है MIT के एल्गो वाले कितने भी कोर्सेज पढ़ोगे ना, सब के सब बहुत ज़्यादा फॉर्मल होते हैं, तो फॉर्मल में फिर इंट्यूशन नहीं आता है। वो जब एब्स्ट्रैक्ट पढ़ाता है या मैथमेटिकली पढ़ाता है तो ज़्यादा इंट्यूशन नहीं आता है, वही प्रॉब्लम हो जाता है बेसिकली। वो कॉर्मेन पूरी बुक ही वैसी है, the entire book is very abstract, but it is, हाँ तो पढ़ने वाले ने पढ़ लेना है। हाँ, Corman proofs are also very good, exhaustive. Like whenever I have to prove things from theory as well as from some standard questions, I refer to Corman and I look at the proofs. So those proofs are robust as well as like formal, and they assume very little theory or very little axioms to begin with. अरे यार RD शर्मा से मत कंपेयर करो उसको लेवल नहीं है वो। RD शर्मा से बहुत बेटर है वो बट मैं ICSE बोर्ड का था तो मेरे को नहीं पता, बट आई हैव हर्ड स्टूडेंट्स, मेरे को RD शर्मा का कहानी पता है, मतलब वाई लोग या फिर शक्तिमान को गंगाधर से कंपेयर करना। किड्स हाँ, इसके बाद तो सॉरी शक्तिमान भी बोलना पड़ेगा। वो पूरा सीन आएगा जिसमें शक्तिमान आएगा, बोलेगा ठहरो रुको, तुम्हें पता है तुम क्या बोल रहे हो, फिर हम बोलेंगे सॉरी शक्तिमान। What is meant by formal? Formal, Karan, is basically mathematical, more to speak. ठीक है. Okay, let's come back to the problem. So now this problem can be solved using a 2D DP. I will just tell you what the DP statement is. Don't ask me how they came up with that. But DPIJ will represent the minimum number of operations that needs to be performed to convert W10 to W20 That's the DP statement. So you have a word W1, you have another word W2, bigger, smaller, any size. DPIJ represents that for this word and this word, what is the total number of minimum number of operations needed to convert this word to this word to this word. That's what DPIJ represents. So the DP statement is two things. You will check the character at I and J. So this is I and this is J. This is the jth index, this is the ith index. So the last index of word W1 and the last index of W2. If both of them are equal, if the characters at index I of W1 and the character at index j of W2, wait, oh, we don't come up with, they come up with the solution and they tell us, and we then answer it in the interview and we get a job.
So can't we solve this? Can't we use a recursive approach first and then simplify it into a DP approach?
Okay.
So if I'm simply constructing a recursion, then I would take a 3-variable approach ABC, which one will be replace R and shorten the length of both. The other would be delete R, shorten the length of one, let the length of the other string remain same.
Yeah, that's basically this solution also. So,
yeah, exactly.
Yeah. Yeah. So see, I could tell you the decision for that, what Karmane is saying as well. So you look at the last character of both the words. If the last character of both the words are same, then so the decision is made on the last character of both the words. If the last character of both the words is the same, then what are you left with? You are left with the task of converting this to this, right? And you have not wasted any operation, right? So then your answer is W1. Your answer is basically whatever the minimum number of operations you require to convert W1 0 to n minus 2 and W2 0 to n minus 2, n2 minus 2. This is n1 minus 2. Right, Pradyum? Does this make sense? I am saying the decision is made on the basis of the last character or the first character. You could come up with any of them. If you look at the last character, okay. So generally for any sequence, the decisions are typically made on the first character or the second character. Now, if you see the pattern in the question, here you have two sequences that are given. So generally you make a joint decision on the last characters of both the sequences. In case of questions wherein you are given two sequences, we will see. So if the characters match, if this is also S and this is also S, then you have to just convert this particular prefix to this particular prefix. Whatever is the minimum number of operations required, that will be your answer. So that's what I am telling here. If they don't match, then you have situations. What could you do? You have something else here. Let's say you have E here and you have S here. One thing you could do is you could replace S with E or E with S. We want to convert W1 to W2. You could replace E with S. So these are the three. Again, the decision here is explicit. You could replace E with S, right? If you replace E with S, what are you left with? You are left with, you have already wasted one operation. And what are you left with? You are left with W1 0 to n minus 2 and W2 0 to n minus 2. Right? This is the first operation that's permitted, which I'm trying to use here. What else can you do? You are allowed to insert and you are allowed to delete. Let's say you go ahead with the task of deleting E. If you delete E, what is the problem? You have wasted one operation and you are left with the problem W1 0 to n minus 2. So now once you delete E, you are left with this problem and this problem. So you have to convert this into this. So you are left with W1 0 to n minus 2 and W2 0 to n minus 1, n2 minus 1, whatever. Do you understand these two? Replacing and deleting others. So I just said the decision is always on the last element. Even in case of one-dimensional arrays, if you have noticed all the questions that we have done, whenever we take a decision of include, exclude, we generally do it on the last or the first element, so that we get a suffix array or a prefix array as the subproblem. When we have two arrays or two sequences, we jointly take a decision on the last element. That's the pattern. You will see more questions wherein we take joint decisions on the last two. So if both of them are same, then this is the case. If they are different, then you have three operations that are permitted: replace, delete, and insert. I told you the subproblem. If you replace, you are left with this and this. If you delete, then you are left with this and this. And can you tell me the third one? If you insert, so let's say you insert S here. What is the subproblem you will be left with? You will be left with this problem and this. Right? So if you insert S, then you have wasted one operation and you are left with W1 0 to n minus 1, the entire thing. And you are left with W2 0 to n minus 2. Correct? Do you understand the insert? I have inserted it here. So now your task is to convert this into this, because now S and S match. Right? Insert also clear? Insert may generally people face problems. I can answer questions if you don't understand insert. So that is the decision. The decision is on the last element, and you have the choices which are given in the question explicitly, that you can do this, this, this. So let's do it on the last element. You could, if you do this, this is what you're left with. If you do this, this is what you're left with. If you do this, this is what you're left with. Correct? So what is the subproblem that you are left with? You are left with two prefix arrays. You are left with a prefix array of W1 and you are left with a prefix array of W2. So that's the subproblem space that we have now. Now see, if you understand that recurrence, then let's look at the subproblem space. You have prefix arrays of W1 as subproblems and prefix arrays of W2 as subproblems. So let's say we write all the prefix arrays of W1 as rows and all the prefix arrays of W2 as columns. So prefix arrays, let's start with the smallest. Let's say the smallest is here, 0. 0 is the smallest prefix array, 0, 0, right? 0, 1 will be the next bigger, 0, 2 will be the next bigger, 0, 3 will be the next bigger, and so on till n minus 1. For W2, you could again write 0, 1, and so on till n2 minus 1. This is n1 minus 1. This is the subproblem space. Now let's determine how are we filling this. How should we go about filling this? So let's assume you are at a given ij. What are the values you would need? You would need this value. What is this value? This value is W1 का same prefix array, W2 का एक छोटा वाला. W1 का same prefix array, W2 का छोटा वाला. Right? Then you would need W1 one small, W2 same. So W1 one small would be this and W2 same. This would be that. So if I number them, this is 1. So this is 1. W1 same. This is 2. This is 2. And what else do you need? You need both one small. This one. Right? So both one small is this. Do you get a feeling of this? So we are using these three values to compute this value. So what is the strategy that we could use? We could fill it row wise again, starting from the, this will be here. Those are the smaller ones because we are using prefix arrays. वो ऊपर वाला होगा. So 2 and 3 will be from the top. These three values we are using. हाँ, बात करते हैं उसके बारे में. Do you understand this? So we could fill it row wise, starting from the smallest sub problem to the biggest. So for the first, we are fixing the smallest value of smallest sub problem for W1, which is a prefix array, the smallest prefix array for W1, which is just 0, 0. And we will fill it for all W2, which is the smallest, then the next biggest, next biggest, next biggest, and so on. Then we will move on to 1. 1 is basically 0, 1 ke liye. For W1, we will fill 0, 0, 0, 1, 0, 2, 0, 3, and so on for W2. And in that order, if we keep filling, we will have values readily available. Right? Is this clear to everyone? Haan, Pradyum, I will answer that question. Any questions on this? I will take a pause. I have told you a lot of things. So, if it is clear, please acknowledge. The decision, the recurrence, as well as the order of filling of the sub-problems. People who have not heard edit distance ever, is this clear to you? The same strategy, the same set of strategies we are approaching, we are applying. The only trick that I give you here is that, so far if you see what for 2D DPs, the problems that we have seen had an array and an integer, right? So there we generally were getting a smaller value of an integer and a prefix array as a sub problem, right? This is the first time we see two arrays as a sub problem, right? So in two arrays, this is the first type of sub problem that we have encountered, which is prefix arrays of both the arrays. And in these, typically the decision we were making were at the last element, right? So for the last element, what was the decision we were making? We were saying that we could either include it or exclude it. And depending on that, we were left with a prefix array and a smaller value of the sum. Here, again, we are making a decision on the last element, but we are making a joint decision on the last element. And we are, depending on whether they are same or not, this is what we are doing. If we are same, then we have this as the sub problem. If they are different, then we could do one of these three things, because that's what is given. So we are trying to apply that set of operations that are given, insert, delete, and replace on the last element of W1. And depending on that, we have the outcome. If we insert it, we are left with some sub problem. If we delete it, we are left with some problem. If we replace it, we are left with another problem. So the pattern is still the same if you really observe closely. We will see more questions wherein we have two arrays, and like we will see longest common subsequence and longest common substring also. And you will realize how the same pattern occurs there also. Okay? So that is the edit distance question. Do you want to code it or should I code it? You understand all the nitty-gritties of this? Let's code this. I will give you similar problems for this, and you can So let's say n1 is word1 dot size. So we have a 2D DP and the sub problems are prefix arrays of word1 and word2, right? So in the prefix arrays of word1 and word2, we are filling row wise. So what are the base cases here? Can anyone tell me? Yes, we can do that, which Ayush is saying. What we can do is, so when we are calculating this row, what are we using? We are using this, this, and this, right? Similarly, when we would be here, we will be using this, this, and this. So this and this don't exist for this. When we are here, we are using this, this, and this. So this and this don't exist for this, right? What are the ways you can handle it? Yeah, the base case is strings are empty. So we could add another layer here like this to signify a empty prefix array or an empty prefix array of W1, empty prefix array of W2. Correct? So what will be the case for an empty prefix array? Now you tell me what will be the value that I will put in this row. So what does this row mean? सोच के बताना, बता के मत सोचना. What does this row mean? This row stands for W1 is empty and W2 is increasing, right? So W2 is in this cell, W2 is empty. In this cell, W2 has only the first character. In this cell, W2 is the first and the second character. In this cell, W2 is first, second, and the third character, right? So what is the minimum number of operations you would need to convert an empty string to these? For an empty string to an empty string, you will have 0, right? For an empty string to W2, to only the first character of W2, what will it be? It will be 1. From an empty string to 2 characters, it will be 2, right? So it will be the length of the W2, the prefix W. Yeah, it will be all insertions. Okay, so this is the first row, how you will fill the empty, for the empty. And for the empty W1, for empty W2, what will you fill? So for empty W2, it means that W2 is empty and W1 here, this cell is empty. In this cell, W1 has only the first character. In this cell, W1 has 1 and 2. In this cell, W1 has 1, 2, and 3. So this will again be 1, 2, 3, and so on, right? These will be all deletions. Correct? Everyone understands how I will fill for the empty prefix array, for the empty base cases? I can repeat if you don't understand. If you understand, we will move on to the code. So let's do that. So what will be our DP vector? It will be a 2D vector. N1 plus 1 will be the size of the first dimension. For the second dimension, you will have N2 plus 1. Let's initialize everything to 0. Let's do the base case. Base case 1 is when W1 is empty. So I could go from 0 to the length of W2. This is the first row we are filling. And I could say dp of 0 I is I. Right? What's the other base case? W2 is empty. So I could go over all possible lengths of W1. And I could say dp I0 is I. So these are the base cases. Now let's do the main case. So we can start from 1 to N1. Right? That will be the, for J, we can start from 1 to N2. That will be the order, right? We are filling row wise from beginning to, from top to bottom. And we will have the cases. We'll say if word 1 I is basically index I minus 1. So that's why I'm writing I minus 1. Don't get confused by that. Because here we are iterating on the length and I want to obtain the index. So that's why I'm writing I minus 1 and J minus 1. So if they are same, then dp ij is nothing but dp I minus 1, J minus 1, right? If they are different, then you have three cases. You can replace. So you can replace it. It will be 1 plus dp. When you are replacing, you will have 1 plus dp I minus 1, J minus 1. If you delete, you will have whatever you have so far. When you delete, you will be left with the task of converting I minus 1 J. Right? And the other is when you insert, so it will be minimum of dpij. This will be all 1 plus because one operation you are wasting. dpi j minus 1. And then finally you can return dp n1 n2. Now ask me questions on this code if you don't understand this code. Everyone understood this? No problems with indexing, lengths, anything? You understood the decision also, right? This decision also is used in a number of questions. Let me show you another question.
Sir, once explain the line number 24.
Explain line number 24. 1 second. This one.
No, the above one. Above one.
Tell me the line number.
Word of I minus 1 is equal to
This
word of
one, 23. So we are, so when we are at a given ij, we are computing what will be the valid answer for word 0 to I, word 0 to I minus 1 and word 0 to J minus 1. So the decision was that we will look at the last character. If the last character is the same, then we will just go to the previous characters of both, and whatever subsequent, whatever prefix arrays we are left with, that will be our sub problem. We have not wasted any operation here, right? because they are same.
So because we are making a DP array of size n+1 and n2+1.
You
We
are
are
asking
writing.
why we are indexing by I-1.
Yeah.
That's because the first character in the word 1 is is 0, right? Is at index 0.
Yeah.
That's why. We could have iterated from 0 to less than n1 and 0 to less than n2, but then we will have to, in all the DPs, we will have to write +1 everywhere.
Okay, sir. Got it.
Yeah, basically the minimum of all the three. But you should understand how we are filling the array and all the DP basics also, because this is a 2D DP. So like we discussed that extensively yesterday as well. Karan, is this making sense? Pradyum, is this making sense?
Sir, what if we make DP array of only size n? How are we going to handle the base case?
Then you will have to do for the first character. So then it becomes difficult. Then your word 1, the base cases are that word one has only one character and word 2 can be anything. So then it becomes difficult, I think. That will be a non-trivial base case. That shouldn't be a base case actually. You can still do it, but think about what should you fill when you have, you will basically use the same logic, this logic only, if you really think. So yeah, so that's why empty is the better one. Yeah, Karan, so how did we iterate? I'm sure you are having problems with the indexing. That's the only thing we have changed here. So if you remember the iteration is here, right? So we said that this is the entire array. This is barely visible. Let's move on to the next slide. So we are saying this is the entire array. We just added one more. So this is from 0 to n-1 and another 0 to n2-1, right? And we said that at any given cell, we are using these three values, right? This was clear to you? Yeah, so basically our strategy was to fill it like this. Then this, then this. This is also clear to you, right? Yeah, so then we just said that we want to handle empty prefix arrays also. So empty prefix arrays and empty suffix arrays, for that purpose, what we did was we added one more row here, one more row and one more column, sort of -1 you could say, but this is basically the empty. These are all indexes, right? So 0, 0 is basically the first, only 0, 0 is from W1 you pick the first element, only this prefix array of W1 and this prefix array of W2, right? That was 0, 0. Correct? So this cell then basically represents an empty prefix array of W1 and empty prefix array of W2. And these cells represent an empty prefix array of W1 and this prefix array, this prefix array, this prefix array, and so on of W2. So that was the cell notation. So now we are iterating. So now this is -1 to n2-1. We just shifted it. We are just doing 0 to n2-1. So I mean 0 to basically n2. That's how we shifted it. There are total n2+1 spaces. So we shifted it to 0 to n2. We said this is the 0th index. This is the n2. So the first index here will basically be the 0th index of W1, right? So that's why we iterated from 1 to n2 here and here also 1 to n2 n1. Okay. So that's the question. We have more questions similar. So this is one problem that I showed you wherein you have two arrays, right? There are more questions wherein you have two arrays as. Let's look at this question. This is 1143. I did not tell the previous question number. Sorry, Purva. But This is 1143. The previous question was 72, right? Edit distance was 72. I think so. Now let's try this question. So you have to find the longest common subsequence of this. Now you see the same pattern here. I will just give you a hint. You can try it and we can discuss it tomorrow. But essentially this problem has the same pattern. You have two words, W1 and W2. You have to find the longest common subsequence of this. The essential pattern is that you are given two arrays and you have to do something on them. So one common decision that you could use is the last element of both. A joint decision on the last element of both. Right? So now let's think. What are the cases? The same cases. If the last element of both of them are same, then what is the length of the longest common subsequence? It will be 1 plus whatever is the length of the longest common subsequence for this and this. Right? Everyone understands this? So this is if they are same. Now what is the other case? If they are different. If they are different, what will it be, Pradyum? If they are not the same. If they are not the same, so think this is A and this is E. What will be the longest common subsequence of these two? The longest common subsequence will be max of, nahin, thoda sa aur socho. Longest common subsequence will be the max of the longest common subsequence that you get for this and this, and the longest common subsequence that you get for this and this. Hai? So you have 2 here. You have W10 to N1 minus 1 and W20 to N2 minus 2. And the other one is you have W10 to N1 minus 2 and W20 to N2 minus 1. So you will, that is the length. So this is the DP here. And now if you see they are, this is again the same. You have prefix arrays as subproblem. And they are, so you could fill them row wise, starting from the smallest prefix array to the biggest prefix array. Fix a prefix array of length something for W1, fill out for all prefix arrays of all the lengths for W2, then increase for W1, increase the length by 1, then fill out for all W2. Right? So it's the same. And generally you will see, I will show you more questions wherein you have, I will actually paste more questions on Slack, which will be similar. So all these are based on the same idea of edit distance. And the decision here is that, again, decision is on the last element, but the decision is on the joint last element. And the decision is if the last element is equal or not. Correct? So we are making a decision, joint decision on the last element, and we are saying if they are equal or not. We have two cases, if either they are equal or they are not. And that's basically how you do this question. Longest common subsequence. Everyone understands longest common subsequence? These are all classical questions, but the pattern underneath pattern is the same. This also is taught in class generally in the AlgoDS course. So if you understand this, then tell me longest common substring. Same question, eh? You are given two words, W1 and W2. You have to find the longest common substring, not the subsequence. the same joint decision, the same decision you can make and you can conclude things. Two cases. Let's look at both the cases. What are the cases? If they are equal or not equal, right? So let's say if they are equal. There is one more subtle catch here which you have to tell me. What will dpij denote? Think about this. This will come from both the facts. We have done a lot of 1D questions on substring, right? So I have done three types of questions. We have done 1D questions on substrings, we have done 1D questions on subsequences, and we have done 2D question on subsequence. Use this to come to 2D substring. What is dpij? पहले ये बताओ आप. In English. LCS I and J तक नहीं, वो कंप्लीट नहीं है.
Ending at I and J.
हाँ, एंडिंग एट आई एन जे होगा, वरना थोड़ी बोल पाओगे आपकी 1 प्लस ये वाला और ये वाला होगा. इन दोनों का कॉमन तो यहाँ पर भी आ सकता है आपका, है ना? हाउ कैन यू एक्सटेंड दैट विद दिस? हाँ, तो उस प्रॉब्लम को ही हटाने के लिए हमने 1D सबस्ट्रिंग में ये कंडीशन लगाया था ना, ये कंस्ट्रेंट कि माई डीपीआई विल रिप्रेजेंट द लॉन्गेस्ट व्हाटएवर सबस्ट्रिंग विद दैट प्रॉपर्टी एंडिंग एट दैट इंडेक्स. और फिर हमने बोला था टेक द मैक्सिमम फॉर ऑल आई जे. तो सेम चीज हम यहाँ भी करेंगे. वी विल कीप टेकिंग अ रनिंग मैक्सिमम ऑल्सो. Right, so if they are equal, then it will be 1 plus dpi minus 1 j minus 1. If they are not equal, then it will be 0. बस इतना ही है. And keep taking the running maximum. So dpij represents the length of longest common substring for 0 to I of W1 and 0 to J of W2 ending at I and J. Correct? So the premise is that our longest common substring can end at any I1 here and can end at any J1 here, right? This could be the longest equal common substring, right? So it will end at a given I1 and J1. So I can take it for all IJ pairs and take the maximum. So that running maximum का एक लाइन रहेगा नीचे आपके कोड में. करेक्ट? सबको समझ आया ये? हाउ मेनी ऑफ यू डिड अंडरस्टैंड दिस? थोड़ा और डम डाउन कर सकते हैं अगर किसी को समझ नहीं आया तो. करण? तो सेम प्रॉब्लम से वी आर जस्ट स्ट्रेचिंग और एक्सटेंडिंग फ्रॉम 1 dimension to 2 dimension, बट द एसेंशियल आइडियाज आर स्टिल द सेम. वी आर जस्ट, if you really think about it, take out some time and think on that, the essential ideas are the same. It's just that we are extrapolating those ideas for a 2-dimensional case. तो सारे आइडियाज वही हैं. करण, आपको कुछ समझ आया? बेस केस आप बताओ क्या होगा इसका? सेम होगा बेस केस, सेम बेस केसेस होंगे आपके. अगर इजी और इजी होगा, बेस केस W1 is empty and W2 is greater equal 0 लेंथ, तो उस केस में 0 होगा आपका, एंड द अदर इज W2 0 है और W1 0 से n-1 है, तो उसमें भी सब 0 होगा, तो सारे 0 भर दो. This is actually an easier version. So this is longest common substring. So I could share, let's see if this question is there on LeetCode or not. So longest common subsequence, try it on your own. I will share the link. This is 1143, by the way. Edit distance was 72, I think. So just making a note. And let's see if we have substring question also. Apparently we don't have a longest common substring here, which is fine. I will find a link from some other platform and share it with you, so you can try out. It should be there somewhere in interview beta. Spot पर है तो spot पर है तो कर लेना spot वाला. ठीक है? So that's basically, so these are all 2D, two-dimensional. So just to sum up what all discussions we've done so far, in 2D DP, we have looked at two types of problems. We have looked at problems wherein you are given a sequence and an integer, and we looked at problems wherein we are given two sequences, and we looked at decisions for both of them. For this, we looked at the knapsack problem. We looked at two types of decisions for this type of problem: include, exclude, and the first solution, those two decisions, right? And here for this, we looked at a decision that check the last element of both of them. That's the decision that we did here. So, and these all we looked at for lengthwise, row-wise filling. So all the DP that we have done so far on 2D has been row-wise filling. We will look at lengthwise filling now, but if everything so far is clear. So let's try. So what's the time? We still have time for one question, right? Spoj is a platform. How to identify a DP question? Generally, you have two pointers. You either are trying to find an optimized solution, maximum or minimum or something, or you have combinatorial questions wherein you are asked to count. Okay, what's up? Like I told this in the first class also on DP. So Spoj is, Karan, basically it is one of the oldest platforms. So when we were in our first and second years, our seniors used to practice on Spoj and then sit for interviews. It was, everything else came from Spoj. So you could think about Spoj as the root. It was the original, the oldest, one of the oldest platforms which enabled you to do competitive programming. I mean, AlgoDS stuff. Then after that, there were all kinds of spin-offs. Topcoder came, CodeChef came, CodeForces came. फिर अभी नए वाले आ गए सारे, इंटरव्यू बिट, LeetCode, और भी बते रहे हैं. Geeks for Geeks तो आपका repository की तरह है. HackerRank आ गया अभी, HackerEarth आ गया. But Spoj is one of the oldest. So Spoj has a lot of classical questions. Okay. For classical questions, you could always do Spoj. Do the top 100 questions of Spoj, you will mostly be done with all types of classical questions on Spoj. Those questions used to be asked when we were kids, when we were in 11, 12 or in our first years in interviews. So it has evolved competitive programming also from there to what we are doing these days. Let's try 1140. I don't intend to start length DP today. We can start it tomorrow. Let's do one order n cube 2D DP question. This is any ideas? This is a relatively tough. This should not be a medium question with all due respect to lead code. चलो ये आप लोग ट्राई करना, ठीक है? इफ यू आर एबल टू डू दिस, जो कर लेगा उसको चीज बर्स्ट मिलेगा. अब तो खुल भी गया है लॉकडाउन. डोमिनोज कॉन्टैक्टलेस डिलीवरी कर रहा है अपेरेंटली. ठीक है, सो ट्राई दिस and we will take up the solution tomorrow. Whoever does it will get the cheese burst. I mean, honestly, if you do it after looking at the solution, then it's another story. मतलब 1000 रुपए के लिए ऐसा ऐसा करोगे तो बातें लगे. ईमान खो दोगे. पैलिंड्रोम वाले वापस आए नहीं मेरे पास. I can help them who help themselves. मेरे को सो DSP 1 में एक पैलिंड्रोम वाली बकचोदी कराई थी. वहाँ पर मतलब they had to come up with the most funniest palindrome that they could think of. So we did that. The winners were, who were the winners? Karan, wow था ना एक? नहीं, wow नहीं था एक winner. अच्छे strings थे. Do you remember any palindrome winner? हाँ, ओफो था एक. अरे ये बहुत अच्छा था, ओफो. This guy got it. I think this was Prakhar, if I remember. So OFO was the winner. There was one more by somebody else. So this guy apparently has been promised a cheese burst. हाँ, तो वरुण सर नहीं भेजे तो वरुण सर को बोलो ना, मैं क्यों बोल रहा हूँ. So let's do this question now. तो वो क्वेश्चन करना पक्का, जो कर लेगा. मैं फोन लेके आऊंगा, उस टाइम ही डिलीवर करूंगा. ठीक है, तो जिससे हो जाए कल डिनर मत करना. This is question 516. Let's. अरे आप घर पे हो, अब घर पे हो तो बातें लगे. पुराना वाला 1140. 1140. 1140 is the cheese burst question. It's a relatively easier cheese burst question because the essential ideas have already been discussed in the class. The difference wala idea has been discussed, and the decision is also something which has already been discussed. That's the cheese burst question. We are doing 516 now. So here in 516, what are we said? What are we told? We are given we are given two words, and you have to find the longest palindromic subsequence. They're given one string and you have to find the longest palindromic subsequence. So we are basically, now we are doing 2D DP, 2D length DP now. This is what we have started now. We were doing 2D DP, which was being filled row wise. This is the first 2D length DP example that we are taking. We will look at the decision that comes with it, as well as what can you do to. So you are given a string and you have to find the longest palindromic subsequence in this string. Let's do a simple one. Let's say that you are given a string and you have to find the longest palindromic substring in it. How will you do this? Let's do this first. Can we span iteratively? What does that mean? Longest palindromic substring तो किया हुआ है ना, किसी ने बताया नहीं. Remember we discussed longest palindromic substring already. We discussed Manasseh's algorithm and another n square algorithm for longest palindromic substring. Today we will look at a DP solution for that. But I was expecting at least one of you will tell me that this is how it can be done. So let's try longest palindromic substring length DP. What can you think about? Look at here, let's talk about the decision. Look at the solution. Let's say this is the solution. This is some I, some j in the solution. What is the characteristic of this solution? This character and this character are the same, right? So what can I do? Can you think? What could be the subproblem? So you could say that, so for any ij, so whatever solution exists, it will start at some index and end at some index, right? So I can, yes, it is a longest palindrome starting at I and ending at j. We can populate all such palindromes, longest palindromic substring and starting at I and ending at j. Right? If we are able to do that, then we can take the maximum. Ab batao, if that is the idea, then what is the decision? Decision is you check this with this. Similar to the decision, joint decision that we've been taking. Right? You'll check this and this. If they are same, if they are not same, let's take the easier one. Then what will be dpij? Will be 0. The other case is if they are same. If they are same, what will it be? It will be the longest palindromic substring starting at I plus 1 and ending at j minus 1 plus 1 plus 2 plus 2 1 I use. हाँ वो ठीक है. 2 plus dp I plus 1 j minus 1. So that's the decision. Correct? Everyone understands this? If you understand, please act and we can move on then. The same patterns. Now you can, if you really think, you can appreciate all the patterns that I have discussed so far. Some ideas from there only we are using. We are using the idea that for a substring we generally find ending at something. We just extrapolated that idea to for a substring starting at I and ending at j. Right? And that's the first idea that we used. Right? So that idea has already been introduced. That is idea 1, if you remember, which is ending at a given index. We have already used that for substrings, right? We just extrapolated that idea to say we want to start also at a given index. And the other idea was the decision. So the decision was the same that we take generally when we have two subsequences, two sequences. When we have two sequences, we look at the last element of both of them, right? Similarly here, when we have a substring that we are looking at, we look at this and this. We are just extrapolating that idea. And we are making a call based on whether they are same or not. I don't know how many of you appreciate this, but yeah, that's basically the idea. Others? Understand? Yeah, so that's basically the DP. Now the harder problem is not this. So what is the sub problem in this case? The sub problem in this case is a subarray. Right? It's not a prefix array, it's not a suffix array, but it is a subarray. Do you understand this? That the sub problem is a subarray. You are looking for a subarray.
Suppose I और j इक्वल है और उस I plus 1 से लेकर j minus 1 तक सब palindrome नहीं बना रहा.
I plus 1 से j minus 1 तक palindrome नहीं बना और I और j सेम है.
तब भी तो ये सीधा मतलब 0 होगा dp of I plus 1 से j minus 1 तक, तो ये तो 2 डाल देगा आंसर में, लेकिन है ही नहीं.
Right. Yes. You are right. How do we take care of this?
चेक करना पड़ेगा कि dp of I plus 1 j minus 1 अगर j minus 1 minus I plus 1 के इक्वल है, मतलब बूलियन ले सकते हैं, आपको चेक कर सकते हैं लेंथ से.
Correct. So you can avoid that case here by checking. So within this also you will have two cases. Ashish is just Ayush has हाँ वो भी सही है, तो सर वही टेक्स्ट बुक सोल्यूशन है जो आप बता रहे हो, बट आयुष ने जो बोला वो भी सही है. So Ayush is saying कि if this has a length 0, then also this does not help, right? If this has a length anything less than j minus 1 minus I plus 1 plus 1, if the length of this, if this value is anything other than this, then also this is not right, right? You cannot have 2 plus this, then it will be 0. So you can check that here. You have two cases that if dp of I plus 1 j minus 1, if it is equals to j minus 1 minus I plus 1 plus 1, then you will say it is 2 plus this, otherwise you will say it's 0. Correct? Did you guys understand Ayush's point and how we will get around that? How many of you understood this point? Yeah, so this is the solution in completeness. So what is the next discussion we were having was how we go about populating this DP array. So how will we go about populating this DP array? That's the next question. So we will look at the subproblem. Let's look at the subproblem. What is the subproblem? The subproblem is for a given I and a j, right? So the subproblem is a subarray, a proper subarray. So, right? So how many such subproblems are there? You have n square such subproblems. You can have all types of subarrays. How can you depict in a visual manner those subproblems? You can depict them in a matrix. For a given I, you can fix I here and you can fix j here, the starting index and the ending index. This will go from 0 to n minus 1 and this will go from 0 to n minus 1. Right? So this is the subproblem space. Now let's see how should we go about filling it. So let's say we are at a given index which we want to fill. So we are at this I and this j. Now what are we using here? We are using I plus 1, j minus 1, right? So we are using this value, not this value, this value. This is I plus 1 and j minus 1, right? So when we are here, we are using this value. When we would be here, we'll be using this value. So we are using a diagonal value. Correct? So how should you go about filling this? When we are here, we are using this value. When we are here, we are using this value.
So diagonal की सारी entries 1 1 1 होगी ना, क्योंकि I equal to JS.
नहीं, प्रिंसिपल डायगोनल का बात नहीं कर रहे हैं ना, कोई भी डायगोनल हो सकता है.
नहीं मतलब वहां से स्टार्ट, वो उसको बेस केस मान के फिर
स्टार्ट करेंगे. यस, यू आर राइट. So the idea is we will fill it diagonally. Correct? So this is a length DP. If you see closely, here we will fill all subarrays of size 1 first. Then all subarrays of size 2, then subarrays of size 3, then subarrays of size 4. This is the order in which we will fill. So what is the base case? The base case is all subarrays of size 1. So they will be 1, right? That is the, for any subarray of size 1, the longest palindromic substring is 1. And then from there, 2, 3, 4, you can fill. So in visually, how are you filling it? Visually, you are filling it diagonally. Visually, you are filling this first. This is 0, 0, right? This is 1, 1. So these are all subarrays of length 1. So visually, you will fill this row first. Then you will fill this row. These are of length 2. Then you will fill here. These will be of length 3. This part is not relevant for you because you are assuming that j is always greater than I. So 1/2 of the matrix you will not be filling. किसको किसको समझ आया ये पूरा कहानी, पूरी कहानी? So this is one example of a diagonal of a DP wherein we are 2D DP wherein we are filling it diagonally. My question to you is, why can't I fill it row wise? I+1 नहीं मिलेगा, yeah, so you are saying you will start, yeah, you will not get I+1 if you fill it row wise, because in row wise you will start from, so you could, no, the question is you could start from here, right? You could fill it like this, you could fill it like this, right? You will have stupid cases like start from n-1 and end at 0, correct?
तो नए रो को स्टार्ट कैसे करोगे, वो नहीं कर पाओगे
क्या?
एक रो कंप्लीटली फिल कर दिया आपने, फिर नेक्स्ट रो को स्टार्ट कैसे करोगे? उसके लिए आपको j-1 चाहिए ना, वो नहीं है आपके पास।
मतलब ऐसा है कि I know this part is stupid, like this part is, let me use a very lighter color, this part is not relevant for us, which is fine, I don't bother about it. I want to fill only this part, but can't I just fill it in this order? I will ignore. For anything before this line, I will ignore, I will not fill. But whenever I cross this line, can I fill it? So when I'm at this row, I would have already filled this row, right? Which means that I would have filled this value. So I can use that value. So my question is, why can't it be done like this? So let's say I am here. Let's say I am here. Here. I have already filled everything till now. I need only this value. क्या बीच में मैच कर रहा है कि नहीं, ये कैसे बताएंगे? मतलब नहीं, वही मैं बोल रहा हूँ. Anything which comes in this yellow part, I will ignore. I will just skip. I will check. If I is less than j, skip. Continue. I will not populate. हाँ, ऐसे भी हो जाएगा. ट्राई करना आप लोग. If it still doesn't convince you, draw a 3x3. Let's draw a 3x3 and show you visually. Simulate. Let's simulate for a 3x3. Let's say this is a 3x3. So if this is the principal diagonal, this cell is irrelevant to me. This cell is irrelevant to me. and this cell is irrelevant to me. Correct? Now how will I start? I will start from this row. I will come at this cell. I will say, oh, I is greater than j. Ignore. Continue. I will come here. I will say, oh, I is greater than j. Ignore. Continue. I will come here. I will say, oh, I is equal to j. So this is the base case. So I will say 1. For this, let's fill it as 1. Okay? Next, I will start from this row. I will say, oh, I is greater than j. Ignore. Now I will come here. Oh, I is equal to j. Right? So I will say 1. Now I will come here. So this is a valid value. So what will I use here? I will use, so this is basically signifying, हाँ बात सेम है, वही मैं बोलना चाह रहा हूँ. बात सेम है क्या, मैं ये पूछ रहा हूँ. So this is signifying 0, 1, 2, 0, 1, 2. So this is signifying, let's draw that array 0, 1, 2. You want 1, 2. So this is the part of the array that we are talking about. Right? So we will check if this and this are equal. If this and this are equal, we will go for 2, 1. I plus 2, 2 minus 1. So basically we will use this value. So these are all base cases, right? For 2 also you can just say, or you can initialize all these to 0 because they are no for your convenience. So if they are equal, you will get 2 or 0. Next you will come to this. You will say, oh, this is the base case 1, 1. You will come here. Here you will read this value. So this will either be 2 or 0. When you are here, you will read this value. So it will be either 3 or 0. So you can fill it row wise also. Did you understand? So you could have 2 strategies of filling. It's not necessary कि जो आपको बताया जाता है वही सही है. You could fill it like this. This is the first row you could fill. Then you could fill this, and you could fill this. In this order you could fill, or you could just fill it like this. Both the codes will be fine. So try it on your own. Try both the codes and convince yourself that it works. प्राइमरी में 1 ऐसे है करण कि प्राइमरी 0, 0, 1, 1, 2, 2. तो स्टार्ट इंडेक्स 0 है और एंड इंडेक्स 0 है, या स्टार्ट इंडेक्स 1 है और एंड इंडेक्स 1 है. तो स्टार्ट इंडेक्स एंड एंड इंडेक्स आर द सेम, मतलब एक 1D सिंगल साइज्ड एक एरे, सब एरे ऑफ साइज 1 हुआ ना. So for this it is 0, it is 1, right? It is always a palindrome. So this is the idea of length DP, wherein we have a subarray DP. Generally in length DPs you have subarray DPs, and you are filling it lengthwise, starting from the smallest length to the biggest length. And the decision that we make is again the joint decision that we've been making for 2 sequences, which is look at 2 characters of the sequence, one from the first sequence and second from the second sequence. So here that was the decision. So here in the subarray we were looking at the first character and the last character because the sequence was only 1. So that's the decision. The another question for this is now longest palindromic subsequence. How would you do that? we will show the code for this. I will show the code for this, but for LPS also, longest palindromic substring also. But now let's say the question is a longest palindromic subsequence. So you are given an array and you have to find a subsequence which is as large as possible and which is a palindrome also. So how would you do that? It's the same, absolutely the same. But you will check for these two for a given ij if they are same. So here, what does dpij represent? There is no ending clause here. It just represents the longest palindromic subsequence for array I to j. Okay, so that is what dpij will represent, and the way it will work is if these two are same, then it will be 2 plus dpi plus 1 j minus 1. If these two are different, then it will be just dpi plus 1 j minus 1. So this will be for same, this will be for different. Correct? Everyone understands this? So the same ideas are being borrowed again and again. Others, do you understand this longest palindromic subsequence? So it's again a length dp, wherein we are going from the smallest length of the smallest subarray to the length of the biggest subarray. So ideally, we would want to fill it diagonally, starting from the principal diagonal and moving upwards. So we will try these codes on your own. I have already shared all these questions on Slack. I will share more questions which are variations of edit distance today, and more questions which are variations of this palindrome. So try them on your own, and I will show you a sample solution tomorrow for length dp questions. How do we go about solving length or implementing length dp? Okay, so that will be the first thing that we will do. We'll do first thing in the morning, in the evening. We will continue and conclude on length dps. We will look at a couple of problems along with the code. I will code it. And then we will start with matrix dp. Matrix dps are generally easier, much easier than length dps. So in matrix dps, you will have a matrix in the question. Till now, whatever we have done, we have seen one-dimensional arrays in the question or two one-dimensional arrays in the question. We will then now see matrix dps, wherein you will have matrices in the question and what kind of decisions we can employ. So matrices are very easy generally. Generally, the decisions are, you can, from a given cell, you can go in 4 directions or 2 directions. So matrix dps are relatively much easier than all the discussions that we've had so far. So we will look at matrix dp tomorrow. And if time permits, we will start with some greedy algorithms. And I will we have at least 3 to 4 types of greedy questions that we can cover. So we'll look at that. And then we will do, we will do dp with graph dp and dp with bit masking also. Which is the next topic after this. 3dp करेंगे हम लोग. 3dp और ग्राफ डीपी एक ही जैसा है. 3dp कर लेंगे हम लोग, ग्राफ डीपी फिर से नहीं करेंगे. और dp with bit masking we will also do. ठीक है, so that's the agenda. If you have anything else you want to include, let me know. I can include that. मल्टी डायमेंशनल नैपसैक का एक क्वेश्चन चाहिए क्या? अच्छा ठीक है, ढूंढ के लाएंगे हम मल्टी डायमेंशनल नैपसैक का एक क्वेश्चन. आपके पास कोई क्वेश्चन है तो आप भेज देना. digit DP is, we have a question on digit DP in the, I will share with you. एक question है I think digit DP का. So digit DP is basically, if you want, we can take it up. Okay, I will include digit DP also. Just give you an idea and a couple of questions maybe. Okay, Kushagar? Yeah. So that's all for today, folks. So today we almost completed 2D DP. We will look at a 2D DP on N-cube question tomorrow and length squared implementation, and then we will move on to matrix DPs. So I will stay around for a couple of minutes for questions. Other than that, thank you all for joining. Good night. Take care. Don't go out. And I will see you tomorrow again. Yeah, Pradyum. Now we can take your question. Yep. 2. Palindrome partitioning 2 करना है ना आपको. यार ये तो आसान है ना.
Sir, could you also discuss game theory like you used in min-max key, right? For stones. One problem is here, right?
Yeah, we have more problems in the game theory is like अलग से theory पूरा नहीं है. Yeah, tell me.
I didn't understand that approach. Could you briefly discuss that?
Yeah, we will discuss when we do so we have 2 more questions on stone games that we intend to cover. I can discuss it. I can try to explain you now also, or we will take up both of these questions tomorrow. So one of them is an order n cube length DP, and the other is an order n square DP. So we will discuss both of them tomorrow, like with code again. So the DP statement will nearly be the same as it was for the first one.
I understood up to some extent. You had discussed 2 approaches, right?
Yeah.
First one is generating all the sequences, and the second one is using differences.
Second one is using
differences.
Yeah, using differences. So we said DP
of I is difference between scores of P1 and P2 for sequence A of I, like that. I didn't get how that approach works.
Yeah. So just look at the problem statement very closely. We are saying that DP of I is representing the difference between the scores of P1 and P2. So we are saying P1 score minus P2 score, assuming P1 goes first. So we are saying DP of I represents the difference between the first player's score and the second player's score. That's it. That's what we are saying. Whoever goes first, his score minus the other person's score. So it is generic enough. We are not constraining it to be of a particular person, right? We are not saying it is of Alice or it is of Bob. We are saying generically that it is whoever is beginning, his score minus the other person's score. So that's the English definition of DP of I. Now, is the English definition clear?
Yes, sir.
Yeah. So if that is clear, then what are we saying? We are saying that the player, whoever is going first again, has 3 choices. Let's say he can take 1, or he can take 2, or he can take 3. Let's say he takes 1. If he takes 1, what is his score minus the other person's score? Let's say he takes A0. What is his score minus the other person's score? From DPI plus 1, you will get P2 minus P1. Right? Because the other person is now beginning.
Sir, how is this changing from P1 minus P2 to P2 minus P1. This is not, I'm not getting it.
Yeah, that's what I'm saying. See, when we are here, we are saying whoever is starting, see, it's an alternating, we are alternating between players, right? That's the essential idea. We are using that idea.
Yeah.
Because we are alternating between players, we are saying whoever is starting now, his score minus the other person's score. This is what we are interested in. So we say that let this player execute a turn. Okay. So let him execute a turn. Let's say in that turn, he takes A0. Now, if I let the other player work on the remaining, which is from 1 to n minus 1. So what we will get will be the other player's score minus this player's score, right? So what will be his total score? His total score will be this plus this. And the other person's score will be this in all. So dp of 0 will be A0 minus dp of 1. Because dp of 1 will give you P2 minus P1.
Okay.
Does that make sense?
Yes, sir.
Because it's an alternating game, right? So dp of 1 will give you whoever turns first, his score minus the second player's score, right? And I am now executing a turn and then calling dp1. So when I'm calling dp1, I know that the other player will run first and he will, whatever dp1 will return will be P2 minus P1. So it is basically saying,
It makes some sense.
this is P1 score, and for the remaining, you will have some of these will be picked by P2 and some of these will be picked by P1. So those, some of them, the difference between these two is what you will get from that. Your total for this will be this plus this minus this. That's what we are writing when we are saying A0 minus dp of 1.
So basically, we have three cases here. Either he picks 1 or 2 or 3.
Yeah.
We are handling each of them separately.
Yes.
And every time I changes, it flips. The player turn changes.
Yeah, I mean, think about it in this manner. We are saying we want the score of the other person. So dp1 will give me whoever turns first. For this sequence, whoever plays first minus whoever plays second, that score. Right? And I know that once I have executed a turn, I need the negative of that. Because I know that for sure dp of 1, it will be executed by the other person because it's an alternating game. So that's why we have a minus here. That's the first thing. The other thing is the decision is it is a minimum or maximum of these three. That is another thing. That has got
I
nothing
understood the significance of minus.
Okay.
It just confuses me why we are using dp of 1. I mean, how it flips, I am not able to get.
So do a dry run then. I think that would help.
Okay.
On a small example, just do a dry run, execute all the DPs.
Okay.
Okay.
Thank you.
And then, yeah, I will explain it to you again if you don't understand.
Yeah. Okay. I think I am able to get it because it's better now. Before.
Yeah. I mean, do a dry run, you will get more intuition. It's like that.
Okay. Thank you.
Yeah, no problem. प्रद्युम्न का क्वेश्चन तो दिए नहीं आंसर, बहुत ना इंसाफी है. इसमें all substrings should be palindrome as well. Yes. So you have to partition such that each of segment within that partition is also a substring, is also a palindrome. तो क्या दिक्कत है इसमें? This is n cube. नहीं, पहले प्रद्युम का खत्म करते हैं, फिर तुषार का लेंगे. प्रद्युम ऑलरेडी इतना वेट कर चुके हैं. या नॉर्मल पार्टीशन डीपी है, सोल्यूशन वही है इसका, इसमें कुछ भी हाथी घोड़ा नहीं है. सो बेसिकली वी आर सेइंग कि look at the solution, look at the first partition. So if you are putting the first partition after I, then what is the criteria? Your criteria is this should be a palindrome, then only this is a valid partition, right? Previous question, the criteria was that this should be in the dictionary. Word break में ये था criteria. यहाँ पर ये criteria है कि this should be a palindrome. तो आप चेक कर लो इसको palindrome, अलग से इस palindrome का routine बना लो और चेक कर लो कि ये पैलिंड्रोम है कि नहीं. तो यू विल गेट दैट एंड देन सो द मिनिमम नंबर ऑफ कट्स इज 1 प्लस whatever the minimum number of cuts you get from here. So that will be dp of I plus 1 and max it for all I, min it for all I. क्या हुआ? नहीं समझ आया. 0 to I की so the question is कि I will just tell you the question. You are given a string, you have to partition it in such a way, let's say this is the partition, each of these partitions P1, P2 and P3 should be a palindrome. So this should be a palindrome, this should be a palindrome and this should be a palindrome. तो हम चेक कर रहे हैं ना. So you are, when you are trying to partition at I, you are checking whether 0 to I is a palindrome or not. And if it is, then you are calling on I plus 1. Partition palindrome 2 is a different question. 2 भेजा आपने, 3 नहीं भेजा है. Given a string S, partition S such that every substring of the palindrome is a palindrome. Every substring of the partition is a palindrome. 3 बोल रहे हो क्या आप? 2 तो यही है क्वेश्चन. सो पैलिंड्रोम पार्टीशन 1 रिकर्सिव वाला है, बैक ट्रैकिंग वाला है. पैलिंड्रोम पार्टीशन 2 ये डीपी वाला है. और एक और है पैलिंड्रोम पार्टीशन 3, आई थिंक आप वो बोल रहे हो. क्वेश्चन का लिंक, एवरी क्वेश्चन का लिंक बताओ यार, मैं भूल जाता हूँ. मेल आएगा. Because there are, why did I get TLE when I solved longest palindromic subsequence recursively? I did not get your question, Arsa.
Sir, I tried the longest palindrome subsequence. I solved it using recursively instead of DP.
But you will get a TLE because you have sub problems, overlapping sub problems, right?
Sir, but we have
So it's
solved
an
many problems
exponential
using
solution.
recursive.
So for
We have solved
Harshan, are you doing memoization on that, or you are just
just recursive. Totally.
recursive, right?
Yeah.
You are not memoizing.
No, not really.
So it will give a TLE, right? Because you are doing, you are solving the same sub problem more than once.
Okay.
How can you see how? When you
When I draw a recursion tree, I could
try this, see if you have this 0 to n minus 1, you would have 1 to n minus 3, right? And then now try for, and then you will have, when you are doing for 0 to n minus 1, you will have 1 to n minus 1 to n minus 3, then you will have 3 to n minus 5, and so on, right? This is the recursive tree for 0 to n minus 1. Now draw the recursive tree for 1 to n minus 3. For 1 to n minus 3, you will have 3 to n minus 5 again. Correct? So when you are doing, you are calculating this twice, in fact, more number of times. So when you are solving for 0, when you are calling that recursive function on f 0 n minus 1, you are computing this. When you are calling that f on 1 n minus 3, then also you are computing this. तो वो exponential हो गया. Do you understand, Harsha?
Yes, sir.
Partition, हाँ, so that's why. हाँ, तो वही क्वेश्चन है ना प्रद्युम. Partition it in a way such that every substring is also a palindrome. Substring लिखा हुआ है क्या? वो substring मतलब वो partition का string है. उसका मीनिंग वही है और कोई मीनिंग नहीं है. सबस्ट्रिंग है ना वो प्रीफिक्स अरे थोड़ी है, सबस्ट्रिंग है. मतलब वो टेक्निकली सही भी है, इंग्लिश गलत थोड़ी है उसकी. ओ एवरी सबस्ट्रिंग ऑफ पार्टीशन आपने बोल दिया. अरे बहुत ज्यादा सोच लिया. सो यू आर सेइंग कि इफ मतलब ये भी पार्टीशन, ये अगर ये चीफ पार्टीशन है, प्रिंसिपल पार्टीशन है, तो आप बोल रहे हो कि इस वाले सब पार्टीशन के लिए ये वाला भी पैलिंड्रोम होना चाहिए, ये वाला भी पैलिंड्रोम होना चाहिए, ये वाला भी ये भी पैलिंड्रोम होना चाहिए, ये बोल रहे हो ना. अरे मर जाओगे, ज़्यादा पढ़ाई करोगे तो. नहीं है इसमें कुछ, वही है, इसमें कुछ भी हाथी घोड़ा नहीं है, सिंपल क्वेश्चन है. वो एडिट डिस्टेंस वाला आ गया तो आप बता देना उसको कैसे ऐसे होता है. मतलब डिसीजन आप बताना कि आई एम थिंकिंग ऐसा ऐसा ऐसा. बना तो सकती हो कहानी, उसके कह रहा हूँ. ऐसा बोलना कि ओके सो आई हैव टू कन्वर्ट W1 to W2. ओके लेट्स सी हाउ वी कैन डू दिस. So let's first try to create the last character of W2. Let's try that. So let's try to create this character in W1. So the idea is that if this is also the same, then I don't need to create it. ये बोल देना. And if this is different, then I will need to create this. So let me try to create it. If I then basically this character is, I can delete. This character is not needed. So I can either delete it and then check for this. फिर वापस वो UDP वाला पूरा कहानी बता देना. मतलब सारे DP क्वेश्चंस वैसे ही हैं बेसिकली. किसी में भी आप वो डिसीजन बताओगे वो समझ थोड़ी आएगा, वो तो थ्योरी है. यूजुअल डीपी क्वेश्चन में नॉर्मल एक्सपोनेंशियल से चालू करके, हाँ वही है. आप डिसीजन यहाँ भी आप बता सकते हो वो चीज़, वो भी इतना बड़ा चीज़ नहीं है यहाँ पर भी. क्या ओवरलैपिंग सब प्रॉब्लम नहीं दिख रहा है क्या यहाँ पर आपको? हाँ तो ये सेम चीज आप रिकर्सिवली बता सकते हो। मतलब स्टार्ट आप हमेशा डिसीजन से करोगे बेसिकली, कोई भी रिकर्सिव क्वेश्चन हो या डीपी क्वेश्चन हो, स्टार्ट सीधा डिसीजन से करो। आप बोलो कि दिस इज द डिसीजन, इफ आई डू दिस देन दीज आर द पॉसिबिलिटीज, तो दिस विल बी द दीज विल बी द सब प्रॉब्लम्स। सीधा वहीं से स्टार्ट करोगे। उसके बाद आप कहानी बनाओ कि ये डीपी है या ये सिर्फ रिकर्सन है, डीपी नहीं है, बट डिसीजन से स्टार्ट करोगे। जनरल रिकर्सन में भी डिसीजन से स्टार्ट करते हो ना आप, यू जस्ट से, तो दैट्स इट। हाँ, विश्वा और ध्वनिल का क्लास लगाएंगे कल या परसों, वो मेरे दिमाग में है। एक बार आप याद दिला देना मेरे को ग्रुप में, ठीक है? कल ग्रुप में लिख देना आपके साथ, ठीक है? सुबह ही लिख देना, कल सुबह लिख देना कि आज ध्वनिल और विश्वा ज्ञान देंगे थोड़ा सा, तो मैं भूल जाता हूँ इसलिए। ठीक है, चलो फिर, ऑल राइट। इफ देयर आर नो मोर क्वेश्चंस, I'll see you guys tomorrow again. Thank you. Good night. Take care. I will end the meeting.